But essentially, I'm just going to provide an introduction, a reintroduction into the VMS Thematic projects, and updates on projects that were active this year will follow that. This is really our partners and affiliations. The VMS Thematic project was really designed and is implemented by the PI. We have Patrick Mercier-Langevin with the GSC, Jacob Hanley at St. Mary's, Mark Hannington, Ottawa U, Steve Piercy at Memorial, Peter Simon Ross at INRS, Meg Stewart at Mount Royal, Thomas Monarchy at Mines, Colorado School of Mines, and Mike Hamilton at the University of Toronto, providing all the key geochron data at Laurentian, because of Bruno LaFrance, John Aird, Phil Thurston, myself, and Taus. So the premise really is that the VMS model is based primarily on deposit scale research and to some extent district scale research. However, the differential base and precious metal endowment of assemblages within the Abitibi greenstone belt and between greenstone belts suggests there are fundamental differences in assemblage scale, tectonic, magmatic, and crust mantle processes, and that these processes may impact metal endowment during greenstone belt construction. The thematic research projects that you'll hear about today that I'll introduce will address differential VMS endowment at the assemblage to greenstone belt scale. So somewhat very close to what you're seeing with metal oceans in that regard, through 3 integrated and complementary projects. It builds on and complements Metal Earth's transects, craton studies, and metal ocean research. So there are 3 major projects. The first one is Project 1, and it's really addressing this question: can assemblage scale attributes and pre-deformation paleontoplastic reconstructions identify unique combination of geological events, conditions, or features that correlate with VMS endowment? Will they allow comparison with the model ocean floor? We really want to identify features or attributes that we can compare to what was being defined as assemblages of the modern ocean floor, and ultimately provide some new insights into Archean tectonics and metallogeny. So Project 1 is 3 parts. One is the assemblage level compilation and reconstruction of the Abitibi greenstone belt. And here we'll be this will be a quantitative or semi-quantitative reconstruction. A lot of the features we're trying to quantify, we're hoping to be able to compare to the modern ocean floor, and Taus will provide an update of that. The next one is the geochemical and petrogenetic evolution of the Abitibi greenstone belt, and Pierre Simon Ross and Octavio Witt will provide an update on that project. The third one is Sedimentary Subprovince Volcanism and Constraints on Geodynamic Environment. Jack Simons, the new research associate, has just arrived from Australia in mid-August. He's been introduced to volcanic and sedimentary rocks, the Porcupine, Pontiac, and English River subprovince. You'll hear more from him in the forthcoming partners meeting. This is the last slide, and it really looks at projects 2 and 3 and addresses these questions. Does VMS endowment and differences in the tonnage grade metal content reflect subtle variations in the age? Essentially, the maturity of the crust has not been recognized. Our focus has been on getting crystallization ages, not trying to find inheritance. Magmas that were metal rich prior to eruptions with the metals available via direct magmatic hydrothermal process. And does the trace element composition of VMS ores fingerprint conditions of ore formation, source of metals that may be correlated metal endowment? So Project 2 and 3A are really very closely linked. They share the same postdoc. Annie-Sophie Tabaud has just been recruited. She's working away in France now. She'll be here in late November. So Project 2 is looking at influence of magma residency on crust and crustal maturity on VMS endowment, and that'll be reported on. That project is just getting going, so there'll be no report on in this partners meeting. Project 3A, looking at the pre-eruption metal and volatile content of magmas. Parel Diao and Jacob Hanley will talk about some of the work on melt inclusions, looking at the pre-eruption metal content of magmas. And the same RA and Sophie Tabaud will be involved in looking at the temperature and oxidation state of magmas with Steve Piercy. And again, we won't report on that one today because it's just getting started. But and the last one is essentially the trace elements constraints on the setting and source of metals in VMS deposits. And David Dycroft will provide an update on that project. So with that, Taus, take over and start with project 1A, please.
My name is Taus Jørgensen, and I'm working on the 1A project. And this is sort of an update on where our compilation is that hopefully we can use to quantify a lot of these features that we want to compare within the assemblages and across assemblages in the Abitibi. So the way we sort of approached the compilation work is by using the GSC Bedrock mapping tool. So you can sort of slide that in under the methodology in a way. One of the things that is really nice about this tool that is working in ArcGIS is that it captures metadata. So on the figure here, what you're seeing is sort of a lot of the line work that we've done for the compilation, and this is just highlighting one of these lines, and you can see that the metadata is sort of present here in the attribute table. So there's a good record of where all of the data that has been used into this compilation is coming from. This is just another example. So on the previous slide here, you can see that this line is from CGM, whereas this one here is drawn from one of the OGS compilations. So the two first iterations of our assemblage map was like relying on Thurston's 2008 compilation and Dubé and Michelin compilations from the recent SUG volume. And just sort of a brief look at that, you can see that there are some differences. There, like the Deloro is in here in dark green. There's a little bit more in the Dubé compared to the Thurston map. And another sort of thing that Dubé and Michelin has done is they have divided some of the intrusions in the Abitibi into two different sort of time brackets that you can see here from the pink and the red colors here. Another thing is that where Thurston had divided some of the assemblages into an upper and lower, this is sort of not done in the Dubé compilation. So I did first an iteration using the sort of Phil Thurston compilation as a guide, and this is sort of just an example of some of the things that we are trying to achieve by really using the actual line work done by both the OGS and the Quebec survey. So on the top left here, you have like an example of like a little part of the Abitibi here with the lithological map by the OGS, and below here you can see Thurston's map from 2008, and you can see that he has assemblage boundaries that are sort of crossing right through a fold hinge in this case here. It seems to be corrected here in Dubé and Michelin-Juven's compilation, but you can still see that like on the lithological map from the OGS, there's like a felsic unit coming down here that is not sort of captured in detail. So one of the things that we're trying to achieve by sort of meticulously going in and redrawing some of these lines is to really capture each of the assemblages, so we are getting sort of correct values when you're trying to sort of measure these different features that you're eventually interested in. So this is sort of a lot of the groundwork before we can extract sort of the derivative data that we're actually really interested in. So you can see that the assemblage map that we're working on now here is really close to the lithological map and are respecting sort of the constraints that we can get from these lithological maps, both on the OGS and on the Quebec side. This is just another example where we have a lithological map here where you can see this light green unit that is sort of continues up here. And a lot of the two older assemblage maps doesn't really seem to take this into consideration for, it might not have been appropriate at the scale that they were looking at it. But again, here we're trying to change that so all these details are sort of captured to get the accurate measurements. So at the end of the day, a lot of line work was done on both sides, and here it's sort of an amalgamation of the Quebec and the Ontario sides with all the line work. And when we then use the GSC tool, we can drop in labels, and we can get a nice assemblage map where it's really constrained by the lithological maps done at the OGS and MERN. So this is just sort of an example of how we can start using this. So this will then sort of fairly easily allow us to do a surface area calculation of the different assemblages, where you can see that we easily can start to get this derivative data from this compilation work. So really, the next step now is to try and merge these two databases, so we can really start measure and quantify these different features that we are interested in. So just some examples of that would be like simple volcanic intrusions of different compositions, coherent volcanic rocks, volcanic plastic rocks, magma affinity, which is tying into project 1B, and then of course also we'll be looking at structures that are also available from the two surveys. So sort of continuing on with the compilation work, we still need to do some iterations. We have a lot of the Middle Earth data that we want to implement. For example, there has been a lot of new stuff done in the Swayze by Ras and Tom that we want to implement, and all the other sort of mapping in the Abitibi that might have provided new ages and stuff like that, where we can refine. So this model will be sort of continuously updated as we go along, and then that then hopefully will allow us to establish these features that best allow us for a comparison across assemblages. And down the road, of course, we also want to try and look at this in 3D with restoration, so we can look at volumes and magma rates and stuff like that. And then, of course, a comparison with the modern environment. So that's about it for a little update on the Abitibi compilation. Yeah, I got a question regarding sort of the compilations that we are really standing on the shoulders of. To sort of talk a little bit to the differences of the two, and I thought the best way to do that was probably to put the two compilations up on the screen next to each other from their respective publications. So on the left here you have the Abitibi compilation by Thurston, and on the right hand side here you have Dubé and Michel Angevins compilations from the SCD volume, and these are really the compilations that we're standing on the shoulders of and are trying to improve on, and also to get it into the format that where we can use it and calculate the features that we're interested in. But you can see here on the left that like one of the things that the Thurston map allowed us to do was to retain the upper and lower assemblages in some of the instances here, and it was like a great first pass to sort of get our compilation going. But as you can see on the right hand side here, there's a lot details added on this newer compilation. And I mentioned the intrusive rocks in this compilation, which is, as you can see, not the only thing that has been improved on the Dubé compilation. So even though sort of the nomenclature is largely borrowed from some of these previous assemblage compilations, it also considered equivalent groups and formations established at the district scale. So you can see that also the sedimentary basins and some of the assemblages here has more detail. Another great thing about the Dubé map is that it's also a GIS map. So that that really comes to fruition when we're drawing our lines in ArcGIS, because we can really easily follow where the assembly boundaries match lithological units. So that's really helpful. And then the other thing is that there's still a lot of unlocked potential here that I didn't really talk about yesterday. But as you can see, if you just look at the faults, there's like, I think there's 2 faults or so on the Thurston map, but this has been significantly upgraded on this newer compilation with several of the sort of the major fault zones that are important. And then another thing that we haven't even gotten to yet is also the gold deposits here. I mean, obviously we are focused on VMS, but there's definitely a relationship there that we need to consider. And all these deposits are in the correct location and at the correct size and grade and stuff. So there's still unlocked potential. So yeah, so these are really the 2 compilations that we're using and are benefiting from. So I just sort of want to stress some of the differences and what we are sort of using them for. So I hope that clarifies that question. I thought I had a little bit of time to answer that since we didn't get a chance yesterday. So that's about it.
Right. Thanks very much, Taus. Hey, just as a question, what scale are you? What sort of notional scale are you doing your compilation at?
I would say about 1 to 30,000 and 1 to 50,000 maps is probably what we have been using.
Cool. Excellent. That's going to be great. All right. Thank you very much for clarifying that.